Hi, today we're going to talk about the cosine rule, and the cosine rule is the other of the major things you want to know about non-right angle triangles. The first one was the sine rule, and we used the sine rule to solve a typical problem where the angle and the sides, they were given in opposite pairs. Like if you have an angle and its opposing side, let's say you have another side, then you can calculate its opposing side. If you have another angle, sorry, you can calculate its opposing side. Or if you have, you can also calculate an opposing angle in that way. You don't necessarily need to calculate the side. But they all work in opposite pairs, and that's why it's really good to use the sine rule. Sometimes you don't have this luxury. Sometimes you have two sides and you don't have any opposing angle. You have the angle that's included in between the sides. So that means that we're going to need something else. So that's when the cosine rule comes into play. So if you look here, I made a nice little drawing for us. If we just look at the top half of it, because this looks like a mess right now. Now this is the cosine rule. However, I've written out in words what typically we would write with symbols. So it looks much easier than what it seems here. But I wrote it like this just to make it clear what we're actually trying to do. So let's say I know the length of side 1, I know the length of side 2, and in between it I have an included angle. Think of this, in one of the classes I talked about side 1 and side 2. They're two pieces of toast, and in between I have my ham or chicken, sausage, or a vegetarian tomato or something. You're making a sandwich out of this corner here.
Tomato's a fruit.
Tomato is a fruit, okay. But you can still be vegetarian and eat a tomato.
Yeah.
Yeah.
It's not a vegetarian tomato.
Okay. It's a very carnivorous tomato that's here in between. So if you have everything concentrated to one, let's say, around one vertex of the triangle, one corner of the triangle, you can calculate the opposing side using the cosine rule. And this you could not do using the sine rule. And how do we do this? Well, check out everything that's above the triangle. The length of the side 3 squared is equal to the sum of the two sides squared, the length of the side squared added to each other, minus 2 times side 1 times side 2 times cosine of the included angle. So that's why this works so nicely. If I would have moved the angle up to here, for example, then I would have been using side 3 and side 1 as my two sides and the included angle up here. Then I would have side 2 squared equal to something, something, something. So this is the thinking of the cosine rule. I can also solve for, if I use my algebra and I solve for cosine of the included angle, which means I shift all of these guys over to the other side of the equality sign, I end up with something looking like this. The cosine of the included angle is equal to side 1 squared plus side 2 squared minus side 3 squared divided by 2 times side 1, side 2. So these formulas are quite long. You're going to have it in a formula sheet on the test and in the exams, so don't worry about memorizing. We're of course more so going to focus on understanding, which is obviously much more important. This is the way these rules look when you're using symbols instead of words, and you might think it looks simpler. Just remember, this only works when you understand that if I have an angle that I choose to call A, uppercase A, what is the lowercase a in the formula is always the opposite side, no matter where in the triangle I write it. Okay, so that's why I have my B here, so lowercase b, which means that my angle C is up there, and the lowercase c, the length of the side, is down here. So let's try to solve a problem using the cosine rule and see how it can help us. So I'm going to make a drawing of a triangle here. Let's put the vertical bar here. So let's say that I have a triangle that looks something like this. Okay, it looks like 90 degrees, but that's just because I'm not so good at drawing. This should be 101 degrees. So forget SOHCAHTOA, forget Pythagoras theorem, because it's not a right angle triangle. Let's say another piece of information given is that this side is 32 degrees. And let's say that I know that, let's see, what do I know? I know that one side length is 16 and the other side length is 21. And I want to calculate the missing sides and missing angles. So one problem, if you only learned about sine rule, then you know that sine of 32 divided by 16 is equal to sine of 101 divided by 21. But that's not going to help me to find the unknown angle here or the unknown side up here. So I can't use the sine rule for that. So let's try the cosine rule instead. So first of all, I'm going to put some names here. I'm going to write angle A here, which means that 16 would be my lowercase a. If 101 is my angle C, I could also have written B if I wanted to. Somehow I chose C, then this is my lowercase c, which means that the unknown angle, I'm going to choose to call it B, and the unknown side on the other side is going to be lowercase b. So this was my very start. First of all, because in all triangles we have the fabulous property that the angle sum of a triangle is 180 degrees. So my B is just 180 degrees minus 32 minus 101. Minus 32 degrees minus 101 degrees. And this will turn out to be 47 degrees. 47 degrees. So I didn't need my cosine rule for the size of the angle B. I just know that it's 47 degrees. I am putting this in here just to show that you can sometimes use simple solutions like grade 7, grade 8 type solutions, even to problems that occur in grade 10. Okay, however, what is the length of my B here? I still don't know that. Well, look at this now. My angle 47 is included between 21 and 16. So this is creating almost like a sandwich in between on both sides of this angle B here. So let's try to find using the cosine rule here. So I'm going to have that my B squared is equal to 21 squared one side plus 16 squared the other side. So 21 squared plus 16 squared minus 2 times 21 times 16. If I'm going quickly, just remember that I'm following this formula. It's the copy-paste exercise of the century. 21 squared plus 16 squared minus 2 times 21 times 16. Press pause and go back in the video if you're still confused. It's just a copy-paste, really. Times cosine of A, so I'm still not done, times cosine. Here I wrote A, but what's important is it's not the name A. I put my name here in my example, but I could equally have put it here. The names can be changed. What's important is that it is the included angle. And the angle included here was my 47. So this is, after I have understood this, here is a mark to get in the test, by the way. After I have understood this, it's more so an exercise with numbers. 21 squared is 441. 16 squared is 256. Minus 2 times 21 times 16 is going to be minus 672. Cosine of 47 is going to be something to the effect of 0.682 or something similar. If I do this carefully now, I will get an answer that's more or less equal to 238.697 units long. But please remember that number one, I'm not going to round this answer. Why? Because I'm still not done. This was b squared. B squared is equal to this. So b squared equal to 238.697. But when you meet Obama in the board meeting of the UN, he doesn't want to know what the length squared is equal to. He wants to know the length of the triangle, of the side of the triangle, because we're all practical people here. So we need to take the square root of 238.697. If I take the square root of it, I'm getting something like 15.45, which is more or less equal to 15. So B, let's round it to 15. So here, it's a very good example for how I used the cosine rule. Now, both the sine rule and cosine rule can be used to find angles or sides. If you remember, in the sine rule, I used a problem that calculated the angle. So I needed my sine minus 1 thing. In the cosine rule, you obviously need cosine minus 1 if they're asking you for the angle. So yeah, that's important to remember. One last thing is the area rule. And the area rule I choose to include in the video about the cosine rule because it uses the same thinking of the included angle. So the area rule is nothing else but a half times the length of one side times the length of another side times sine of included angle. So once again, I need to know what is my A, what is my B, what is my C. Let's go back to our problem here. And I ask the question, what is the area equal to? What is the size of this triangle? So this angle was 47 degrees. Okay, so let's see how I can use this. If I choose 21 and 16 to be my sides, the only included angle is my 47 degrees. So in this example, it will be a half times 21 times 16 times sine of 47. And I'm going to leave it open to you to calculate what this is equal to. Please be aware that if the length of the sides is given in, let's say, centimeters, you will see it in the problem. Then whatever number you get here, the unit will be centimeter squared. Okay? I'm going to leave it as an open problem to you to calculate what this actually is. It's just 0.5, which is a half, times 21 times 16 times sine of 47. Make sure that you calculate sine of 47 first, especially if you have a simpler calculator, that you don't make any BEDMAS mistakes. Okay, is that all? Did I include everything? Yeah, okay, so good luck with your studies. See you next class.